In today's video, I'm going to teach you how to perform a one-sample t-test in Excel. We'll walk through what it is, set up a small example, run the calculations with simple formulas, and interpret the result so you know exactly what it means for your data. First, open Microsoft Excel. You can use a blank worksheet. A one-sample t-test checks whether the average of a sample is meaningfully different from a reference value, often called the hypothesized mean. Think of questions like, is the average score different from 75? Or, is the average weight different from 50 kilograms? The null hypothesis says the true mean equals that reference value. The alternative says it doesn't. The test statistic follows this structure. T equals the sample mean minus the hypothesized mean, divided by the sample standard deviation over the square root of the sample size. In symbols, T, E, X, M, S, N. Here, X is the sample mean, is the hypothesized mean, S is the sample standard deviation, and N is the sample size. Let's use a quick data set. Type 5 numbers in cells A1 through A5, 78, 82, 75, 80, and 85. Our hypothesized mean will be 75. Now calculate the sample mean in an empty cell with each one's average, A1, A5. Press Enter to see the average. Next, find the sample standard deviation with STDV, S, A1, A5. Use STDV.S because we're treating these values as a sample, not a whole population. Then count how many observations you have using also count A1, A5. That gives you N. With those pieces, compute the t statistic. In an empty cell, enter ECU average A1, A5, 75, STDV, S, A1, A5, SQRT, count A1, A5. This bundles the steps into one formula, the difference between the sample mean and 75 divided by the standard error. With these numbers, you should see a t-value of about 2.85. To convert that t-value into a p-value for a two-tailed test, place the t-value in a cell, say B1, and use each-shot t dist.2t aabs B1 4. The 4 here is the degrees of freedom, which is uion minus 1, and since n is 5, df is 4. If you prefer to automate that part, you can use count A1, A5, 1 for the degrees of freedom. Interpreting the p-value is straightforward. If it's less than 0.05, you have evidence of a significant difference from the hypothesized mean. If it's greater than 0.05, you do not have evidence of a significant difference. In our example, a p-value around 0.02 would indicate the sample mean is significantly different from 75. A quick tip: the t-test assumes your sample is roughly normal and observations are independent. With very small samples, outliers can strongly affect results, so review your data first. If the video has been helpful and want more tips, please subscribe to the channel. It's free.